let's check out the top 5 facts you must know about kinetics and equilibrium for the Chemistry Regents exam. All right, here we go. Number 1, collision theory. In order for a reaction to occur, hey, particles have to collide. Not only do they have to collide, but they have to have the proper energy and proper orientation. And yes, that wording has been used on the Regents exams. And more importantly, a few of the last Regents exams. So again, proper energy, proper orientation, or collision theory. Number two goes along really with number 1. It makes sense. If you increase the collisions between particles of a substance, yes, the reaction rate is going to increase. There are several ways that reaction rates increase, right? Including temperature, pressure if they're gases, concentration, catalysts, okay, that change rate of reaction by increasing collisions, which brings us to number 3, catalysts. So first of all, you need to know what a catalyst is, and you need to know the definition based on the Chemistry Regents exams. So as it says here, it's going to add up, it's added to speed up a reaction, and it's going to provide an alternative pathway, meaning going from reactants to products, and lower the activation energy as a result. So providing an alternative pathway and lowering activation energy is what you need to know about catalysts. Then we get to number 4, equilibrium. So equilibrium is when you have a forward and reverse reaction happening at the same time. And once you've achieved that the rate of the forward reaction, meaning going from reactants to products, is equal to the rate of the reverse reaction, products back to reactants, is happening at the exact same time, you have equilibrium. That is what's equal rates. The concentrations are not necessarily equal. They will remain constant, however. All right, finally, number 5. What does nature favor? Nature favors high entropy, which is the amount of disorder or randomness of a system, and lower enthalpy, meaning that my products are at a lower energy state than when they started as the reactants. Now, entropy itself, if you're asked about entropy when you look at a reaction, you're looking at the phases. So more disorder and randomness is going to go when you go from a solid to a liquid, for example, or liquid to a gas, or solid directly to a gas, or you have, let's say, a salt and water, and now you're going to mix them as an aqueous solution. For enthalpy, also known as heat of reaction, delta H, there is also reference table I that lists just a small subset of reactions that are either endothermic or exothermic. And it's our exothermic reactions where energy is released and we're going to get this lower energy state. So these are top 5 facts you need to know. I am going to do a separate video, check it out, on potential energy diagrams and what information you need to know and how to read them, and also questions with regards to Le Chatelier's principle, which is when I have a system at equilibrium and now I add a stress, which is now going to shift either the forward or reverse reaction rates to go faster. All right, so check those out and keep working hard. Good luck.